Welcome to my class. I'm your teacher, Madam Kong. Today we are going to discuss about 3.2 periodicity and the tutorial for 3.2 as well. Are you ready? Let's start.
Right.
Yes.
Okay. So just now we have done the explanation about shielding effects, effective nuclear charge, and the size across period, the size of an atom across period, first row of transition element, and the size of the element that going down group, and compare the atomic radius of an element and its corresponding ionic radius, means atom versus cation, atom versus an ion, and isoelectronic species. So all about here, all the case 1, 2, 3, 4, 5, all about size. Here, case B and C is about the ionic radius. Okay, and then for A, right, when the cross period for the atomic or ionic radius, right, we are using the same explanation. So the case 4 is between the atom with its ion, cation or anion, and the last one is about isoelectronic species. Now we need to move on about ionization energy. Actually, right, for ionization energy, the explanation for across period and going down the group, right, is similar with case 1 and case 3. Okay, but here we need to check what is the definition of ionization energy. Same thing happens for electronegativity. The explanation of the variation in electronegativity of element across period and going down the group actually more or less the same. Only the last part is different because last part we talk about electronegativity. The last point we talk about the ionization energy. But before that, all the explanation is the same. So that's why if we check the general explanation, we can see, okay, we go for the general first. Okay, this one. If you check, right, across period, what happened to the ionization energy? We are using the same explanation as well. Proton number increase, effective nuclear charge increase. Now the nucleus attraction towards the valence electron stronger. Atomic size becomes smaller. So you check point 1, 2, 3, 4 is the same for across a period. What happened to the atomic size? Now, if we check the definition for ionization energy, right, is the energy required to remove an electron, okay, from a ground state of the atom or whatever lah, you check, okay. So the main point is valence electron. You have to remove the valence electron. You just imagine when across the size, when across the period, okay. When across the period, you check the size getting smaller. So meaning that the nucleus and the valence electron, the attraction is stronger. Okay, so for example, okay, here is Madam Kong at the first row. Okay, Madam Kong, this is Madam Kong. Okay, first row, second row, third row, fourth row. So if I can more focus on the first row student, compare those who are at the last one. Okay, I can attract more strongly for the first row student who sit at the first row. So if you want to run away, you want to run away, it's very difficult because Madam Kong is here. Easily for me to pull you. Okay, no, please sit back. Okay, sila duduk balik, jangan bergerak. Senang je. So this is the same meaning. So valence electron difficult to remove when the size getting smaller. Why? Because the attraction is stronger. Okay. Now, if you want to remove that electron, right, you need more energy. When more energy is required, so IE increase. But if going down the group, what happened? Okay, the size getting smaller. Okay, the size getting smaller. Why the size getting, the size getting bigger, the size getting larger or bigger. Why getting bigger? Why getting larger? Because the number of shell increase, the shielding effect increase. Now, what happened to the attraction? Weaker. So if I want to remove the valence electron, okay, when n equal to 2, 3, 4, 5, 6, okay, when n equal to 6, okay, the nucleus attraction with the valence electron is further away. Attraction weaker, so easy to remove. Easy to remove means less energy is required to remove the electron, so IE decrease when going down the group. Clear? Okay, clear? Any question? Yeah. So the explanation here all the explanation is the same as going down a group. What happened to the size? Just you have to add more, less energy is needed, so IE decrease when remove an electron when going down a group. Same thing happened to here, all the same, but it's more difficult, more energy is required to remove an electron because ionization. That's why ionization energy increase. Same thing happened for electron negativity. Okay. Of course, you must know what is the definition of electron negativity. It's the tendency to attract the electron to itself. So this one need to add electron. So if you check, right, the explanation for here is the same, still the same. Okay, proton number increase, effective nuclear charge increase, so the attraction stronger, atomic size becomes smaller. It's the same. Now easy to attract electron. That's why electronegativity increase across the period. Tadi ionization energy nak buang, electronegativity lah nak tambah elektron untuk membentukkan ikatan. Kalau nak tarik electron size kecil, okay, attraction between the nucleus, okay, and the valence electron stronger. Kalau you nak tarik, senang je. But when going down the group, yes, number of shell increase, then shielding effect increase, attraction weaker. Because the size is big, so difficult to attract the electrons. Contohnya sini Madam Kong. Kalau I nak tarik belajar kat hujung sekali, susah nak tarik. Okay, that's why electronegativity decrease. Maksudnya tendensi untuk menarik elektron, okay, untuk membentuk ikatan sudah berkurang. So is it very simple? Because all the explanation for the front part is the same when going down a group or across a period. Just the last part you have to define. Okay, electronegativity means added electron. Okay, attract the electron. Okay, whether it's difficult or easy to attract. If easy means electronegativity increase. If difficult to attract the electron means electronegativity decrease. Okay.
Madam,
Yes.
can we write electron instead of valence electron?
Okay. Because okay, we check the you talk about electronegativity, right?
Yes.
Okay. Let's try to check the definition. So if definition, we have to refer to lecture notes. Good question. Okay, we will try to check the lecture notes. Always refer to the definition. Ada soalan tanya, jangan senyap je. Kena faham. So after you check, right, across a period, what happened to the size, what happened to the ionization energy, what happened to the electron negativity, you notice, right, there is a trend. Okay, the explanation is the same. Okay, same for going down. Okay, the different part is the atom versus anion, cation, or isoelectronic species is different. Later, we have to discuss another two parts about ionization energy. One is about the anomalous cases, another one is about the successive ionization energy.
Madam,
Yep.
ada cara tak nak supaya kita ingat apa beza effective nuclear charge dengan shielding effective charge? Sebab takut tertukar. So clear sikit nak bezakan dia.
Okay, cara ingat. Tak apa, nanti cakap. Okay, kita sambung sini dulu. Okay, electronegativity is a chemical properties that describe the tendency of an atom to attract electron or electron density toward itself in a chemical bond. This is the definition. So atom with strong attraction of the nucleus and the outer electron have the high electronegativity. So this is a definition. Okay, so this is a strong story. Across period, and okay, because here using valence electron, attraction between the nucleus and the valence electron becomes stronger. So the atom has greater relative tendency to attract electron to itself. Yeah, can. Yeah, based on your lecture notes right here. Yep.
Both can use.
Yes, can.
Okay, thank you, madam.
Okay, here using outer electron. So meaning that outer electron and valence electron is the same. But why sometimes using valence electron? Why sometimes using outer electron? Okay, this one you have to refer 3.1. Because right, 3.1 you notice right, okay, 3.1 did mention the S. 3.1 did mention right for the S and P orbital, the outer electron and the valence electron is the same. But for D orbital have to be careful. Why? Okay, because 3D, for example, 3D 3 and then 4s2. Okay, the 4s2 is referred to the outer electron. 4s2 is referred to the outer electron. But the question asked about valence electron for D block element is this one. Okay, madam ulang Kalau bagi S block ataupun P block element, outer electron, valence electron is the same. Tapi bagi D block element kena berhati-hati, valence electron masih rujuk kepada prinsipal kuantum yang paling tinggi which is 4s2. Sorry. Outer electron 4s2. Valence electron, because valence electron is used to determine the group. Valence electron is used to determine the group. So we have to refer the 3D and 4s. Okay, so 3 plus 2 equal to 5. So this one is group 5. Okay, Tadi ada orang tanya macam mana nak confuse Sebenarnya 2 term je. Kat sini dia hanya 2 term je. Dia tak banyak. That's why slide yang pertama. Nampak tak? Madam dah buat. Effective nuclear charge memang untuk across the period. Shielding effect down a group. Jadi nak ingat macam mana? Semua orang ada cadangan? ENC period. Shielding effect down a group. Oh, senang je. Okay, shielding effect. Apa tu shielding effect? Shielding effect ialah, okay, satu bulatan, 2 bulatan, 3 bulatan, 4 bulatan. So, ini semua N berbeza. N dia berbeza. Semua dia N berbeza. Contohnya ini N5 ke, ini N4, ini N3, lagi N2, N1. Kerana N berbeza, shield maksud dia menghalang. Dia menghalang. That's why apa yang akan menghalang? Kerana petala yang berbeza akan menghalang nukleus dengan elektron yang agak luar sekali. Dia menghalang. Shield maksud shield ialah menghalang. So that's why apa yang akan menghalang? Sekiranya semakin banyak petala yang lain, jadi dia menghalang. So kalau petala berbeza, maksudnya group berbeza. So that's why it's going down group shielding effect. Okay, effective nuclear charge ialah charge. Dia charge. Mengapa charge berbeza? Kalau going down the group charge dia sama je. Tapi effective nuclear charge across period berbeza. Tadi lithium kan, lithium 3 tolak 2. Lepas tu beryllium 4 tolak 2. And then boron 5 tolak 2. Kemudian charge berbeza. Charge 1, charge 2, charge positif 3. Kerana charge berbeza, mengapa dia boleh charge berbeza? Kerana across period effective nuclear charge berbeza. Okay, kalau going down the group effective nuclear charge is the same. Okay, harap dapat konsep ini senang membantu anda faham. Okay, boleh? Tengok gambar Raja Madam ni. Nampak tak? Effective nuclear charge when going down the group. Sama je. Positive 1, positive 1, positive 1. Yang berbeza ialah N. N2, N3, N4. So, menghalang. Lebih banyak petala menghalang. That's why shielding effect is used to explain going down the group. And then for across period, you check. Okay, the charge is different. Only across a period, the effective nuclear charge is different. Yeah. So this is the basic concept. So electronic species, you kena sit down and then jangan confuse, jangan gerabah, duduk tengok betul-betul apa yang dia tanya. You baru boleh jawab. First, write down the electronic configuration and then check the N value. If N value is different, shielding effect. Okay. And then if 1s2, 2s2, 2p6, here 1s2, 2s2, 2p6, okay. Electronic configuration is the same. So, kita tak boleh cakap pasal shielding effect dah. Kerana N sama. Maka, automatically ialah effective nuclear charge. So, pergi tengok. Oh, yes. Positive 5, positive 6, positive 7. Okay, yes. Nuclear charge, effective nuclear charge, different. So, when getting increased, charge dia besar, maksudnya dialectical attraction. Okay, attraction between the nucleus and the valence electron is stronger. Okay, so because right later you refer back to the definition. Okay, to the definition of effective nuclear charge. Okay, the effective nuclear charge in them is the positive charge felt by an electron. Okay, positive charge. If the positive charge increase, right, meaning that the electron closer to the nucleus experience greater nucleus attraction. If you check for the screening effect, it's caused by the mutual repulsion between the inner electron kat dalam, and the outer shell, the repulsion. Jadi semakin banyak inner electron, jadi repulsion between, okay, repulsion semakin banyak lah. Tapi attraction between the nucleus and the valence electron weaker. Semakin banyak petala when the N increase. Yeah. Okay, now we move on. Okay, let's check what the question asks about for the ionization energy in the tutorial. Okay, first, define first and second IE. So you must know what means by first and second IE. And then state the factors that affect the ionization energy. So when you give the definition, right, you must come together with this equation. Huh? So if you notice, right, initially is gaseous atom. So the first ionization energy of an atom is the energy required, okay, minimum, another minimum, energy required to remove one more, and electron also acceptable for one, okay, kalau sini one, kalau one more, okay, of gaseous atom to produce a positive ion. Second ionization energy dari positive ion ni sambung lah. Okay, is the energy required to remove one more of electron from one more of positive ion. So remove one more of electron from one more of positive ion in the gaseous state. Okay. So there are three factors: size, effective nuclear charge, and shielding effect that affect the ionization energy. Okay, tadi kita ada dah terang dah. Kita kena tengok size dulu. Okay, first we have talked about size. Size smaller. Okay, size smaller. Why size smaller? Because effective nuclear charge increase. Okay, this one, size bigger or larger. Why size bigger or larger? In this case, it's due to the screening effect. Shielding effect. Screening effect is the same. So that's why there are three reasons to affect the ionization energy. Shielding effect, effective nuclear charge, and size. So size sebenarnya dipengaruhi oleh effective nuclear charge ataupun shielding effect as well. So dia ulang balik benda yang sama. Okay. So after definition, okay, after the factors, right, what is the next? The question asks about, okay, successive ionization energy. Okay, what is successive ionization energy? Okay, so successive ionization energy right, always increase because each subsequent electron is being pulled away from its increasingly more positive ion that require more work. Okay, if you check, right, the first IE for beryllium, positive 899. Next, second ionization energy, positive 1757. This is the third ionization energy, meaning that you are remove the third electron, so getting higher. Okay, you need more energy to remove that electron. Because why? If you check from the electronic configuration, right, you should know. This is 2s2. So after you remove the one electron, then you remain 2s1. And then you remove the second electron, then remain 1s2. And then the 1s2, right, the 1 is from the inner shell and the completely fulfilled 2s orbital. That's why you need more energy to remove the third electron. Yeah, maksudnya semakin nak lepaskan ataupun buang elektron ke N yang lebih dalam, you memerlukan lebih banyak energi. So, IE increase. Okay, so this is the concept. First electron, second electron, third electron, fourth electron. So a large increase in successive ionization energy occurs between the removal of the last valence electron and the removal of the first inner electron, because which is closer to the nucleus. So we always talk about, okay, completely filled. Okay, or we use the term full fill. Then we'll talk about the inner electron, or sorry, inner shell. Okay, because why the IE is higher or drastic change? Because the electron is removed from a completely filled inner shell electron. Okay, so we keep on, we'll repeat the same term. Okay, there are two methods to determine the successive ionization energy. One is using different, another one is using ratio. So I prefer you all using ratio. For our syllabus, there are two, but I want you all using ratio. I tak cakap guna ratio ratio jangan pergi guna difference. Okay, so how to calculate the successive ionization energy by using ratio? So we have to calculate IE2 to IE1, IE3 to IE2, IE4 to IE3. So based on the ratio, we have to check which one is the highest. Okay, then we can deduce something. So for example, in this case, the highest is the IE3 to IE2. Okay, meaning that there are two valence electrons, and then the third electron is removed from a completely filled inner shell. Okay, madam ulang kena cari ratio. Kalau tahu ratio yang mana paling tinggi, okay, maksudnya kita boleh deduce dah. Dari IE2 ni, I tahu dia 2 valence electron. Kemudian elektron yang ketiga ni dia buang dari completely filled or fully filled inner shell. Okay, completely filled or fully filled inner shell. Okay, tapi kan, you have to be careful. Okay, this is the proper explanation. Up subshell 2s, third electron removed from the inner subshell. Okay, so that's why a higher IE3 than IE2, or we say IE3, the ratio of IE3 to IE2 is the highest, and then two valence electrons are present. So we know that this is group 2. So we can write down the electronic configuration, which is 1s2, 2s2. Okay, sometimes we're not sure the period for the case for the case A, because here mentioned already from the second period. Second period, that's why I know it's 2s2. If the question didn't mention, we just give the general formula, which is ns2. Boleh Okay. Now in this case, we check. Okay, after that, compare. This one is the highest. I know there are 4 valence electrons, and then the inner electron is from the fifth electron is from the completely filled inner shell. Okay, why? Because highest IE5 to IE4. So the fifth electron is removed from the inner shell, completely filled inner shell. Okay. Since IE5 to IE4 highest ratio, 4 valence electron. Please be careful. 4 valence electron is group 14. The general formula is Ns2np4, not group 4. Because for our syllabus, we just focus on S and P block. Meaning that we can deduce group 1, group 2. After that is group 13 until group 18. So we ignore the group 3 to group 12 transition method. Ignore. We just focus from group 1, group 2, group 13, and to group 18. Clear? The other group 3, the other group 4, group 13 or group 14. So based on the ratio. Again, IE5 to IE4 is the highest ratio, meaning that here 4 valence electron. And then the fifth electron is removed from an inner subshell, from a completely filled inner subshell. Okay, clear. Yeah, ratio method is preferable. Is determine the valence electronic configuration of an element. Any question for the successive ionization energy? Okay, if no, right, let's check the question from the tutorial. Okay, The table shows the successive ionization energy for element J, K, L, M, N. For this out of question, right? No need to think twice. You have to form the table first. You have to form the table like this. Calculate the ratio. Okay, please tell madam which one has the highest ratio for element J? First, second, third, or fourth? Class?
Third.
Yes. How about K?
Fourth.
Fourth. L?
Fourth.
Okay. M?
First.
Then N. Okay. So this is the first thing you need to do to solve the question related with successive ionization energy. Calculate the ratio. Okay, so based on here, right? Okay, I know this one is J is group. Group.
13.
Yes, group 13. Here?
14.
Yes. Here?
14 also.
14. Here?
Group
For M?
1.
Yes.
11. 11. Oh, one. Oh my god.
Group 1, because just like I did mention, we just focus for group. Where is my PowerPoint? I'm not sure which slide I'm drawing already. So we just focus on group 1 and group 2. I think here, right? I didn't save. Okay. I did mention we just focus on group 1, group 2, and then group 13. Start from block P. Okay, be careful. Okay, never mind. Good. At least you start confused, you know, right? Something. So this one is group.
2.
How about N? 2, yes. Okay, I always remember for successive ionization energy, we just focus on S block element, which is group 1 and group 2. And then P block, okay, from group 13 until group 18. So for the between the transition, all the transition matter, right, from 3 until 12, ignore. 3 until 12, ignore. Group 3 until group 12, ignore. Okay, so after you analyze the highest IE ratio and the group of each element, right, then only you can start to answer the question. So for example, explain which element will form ion with charge of positive 1. So for sure it's group 1 element. Okay, group 1 element will remove 1 electron to form positive 1. So M. How to explain? Because the ratio of IE2 to IE1 is the highest. Okay, if you want to add it, so if from group 1 element, so group 1 element tend to remove 1 electron to achieve octet. Okay, and form the M positive. Get it? Clear? So the main reason you must mention about IE here, so you must mention this one. The ratio of IE2 to IE1 is the highest. Then you can add, okay, it can form M positive ion because group 1 element tend to remove 1 electron to achieve octet. Some sort like that. Okay, second question. Explain the which two elements belong to the same group. Okay, group 14. Group 14 means element K and element L. Okay, next. Explain difference the first ionization energy value of these two elements. So we check for group, we check for K and L. Okay, what can you deduce from these two values? Okay, what can you deduce from these two elements? Okay, since I use a simple example. Okay, just example. Okay, lithium, sodium, potassium. If I want to remove the first electron for these three elements, because all with 1 electron, right, positive 1, right, meaning it tend to remove 1 electron. Okay, which one has the highest, which one needed more energy? Which element need more energy to remove the first electron? Lithium, sodium, or potassium?
Lithium.
Lithium, very good. Why?
Because the shell is smaller.
Okay, the
Atomic
inner
energy.
shell, okay. Then principal quantum, the value of principal quantum number is the smallest. Then
And then the screening effect is smaller.
Yeah, can the screening effect is smaller. Very good. So what happened?
So the energy required is more to
Talk about attraction first. Good try, Vicky. Good try. So we have to talk about the attraction between the nucleus and the valence electron is the weaker. So that's why the energy needed, okay, is the lesser. Okay, yes, lithium, very good. So based on here, K and L. So how do you explain K and L? Of course, you have to explain in terms of the position. So like this case. So which one has higher position? For K or L? Which one has higher position in the periodic table? K or L?
K.
K. Yes, very good. Okay, K. Okay. So the first ionization energy for element L is lower than K because L is in lower period than K. Or you can mention the first ionization energy for element K is higher than L because K is in higher period than okay, well, very difficult to explain, right? So now you just refer to here, don't be confused. So KL. So I know the position is like this. KL. So then check. You can explain lower or higher, up to you. So in this case, L, okay, ionization energy, L is lower than K because L is in lower period than K. Okay, or you can twist. The first ionization element for K is higher than L because K is in higher period, okay, higher period. Or you can mention the principal quantum number of K is smaller. Then talk about the size. Talk about the screening effect. And then talk about the attraction. Okay, clear? So from group 14. Okay, up to you how to organize your sentences to explain the answer. Once you get the concept, you just sit down. Okay, you know this is K. Okay, this is L. You can talk about the N, the principal quantum number. You can talk about the position of. Then only link the value of IE with the N value or the position of the periodic table. Then continue with the standard answer: atomic size, screening effect, attraction. Okay. Before we proceed, question 9, let's check question 12. Okay, let's check for question 12. For successive ionization energy, right, or ionization energy, first we can deduce based on the table given, the data given. Another one is based on graph. Here, based on graph. So you must understand, you must interpret the graph first. Okay, that's why for this, right, I did mention, explain the increasing of the successive ionization energy, okay, based on graph or table. So table we have done already by using the ratio method. Now we go for graph. So the first question I would like to ask, here 1s2 or here 1s2, A or B? So in this case, there are 13 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13 electrons for element Z. So how to read the graph? 1s2 is B or 1s2 is A? A or B?
B.
B or A? Everyone please write your answer over the
B.
comment. Everyone please write your answer over the comment, A or B. I have to check. Oh, no. This no. Okay, let's check. Okay, I want to check the answer. Wow, most of you answer B. Okay, B. Okay. Yeah, very good. The answer is B. Why? Because the inner electron, this one is the innerst electron, paling dalam sekali. That's why IE, this is IE. IE dia paling tinggi. Okay, IE dia paling tinggi. Yes, the answer is B. Kita tahu semakin dalam ionization energy dia semakin tinggi ya. So the answer is B. Okay, so let's continue. So I know here is 1s2, then here 2s2, and then here 2p6, then 3s2, 3p1. So state the group and the period. Okay. So I know n equal to 3. So it's period 3. And then valence electron 1 plus 2 equal to 3. Since this one is p block element plus 10. So this is group 13. So state the group and period. Should be no problem. Okay, period 3, group 13. Okay, next. Why a higher energy is needed to remove the fourth electron? You see, the fourth electron is here. Okay, the fourth electron based on electronic configuration, you know something. The fourth electron is from here. Okay, from n equal to 3, then change to n equal to 2, meaning that this is completely filled. Okay, inner shell. Okay, please add a completely filled or full fill, completely filled or full fill inner shell. There are 2 marks. One is due to the inner shell, another one is due to the completely filled inner shell. Okay. Next, explain how the atomic radius change when an electron is added. When electron is added, means become an ion. So M ion sure the sign is increased. Okay, remove or added. Oh, remove, sorry. Remove, right, means cation. Sorry, remove means cation. Okay, remove means cation. If cation, the size is smaller. Okay, this one added anion. So anion, the size is bigger. Always remember, if compare with the compare atom versus the ion, cation, the size is smaller. Anion, the size is bigger. So atomic radius decrease for cation, atomic size increase for anion. Okay, most stable oxidation number means I will remove the n equal to 3. So I will remove 3 valence electrons. So that's why it's positive 3. Okay, clear? This is about to deduce the position of an atom based on graph. Okay. So what happened to question 11, 10, 9, 10, 11? Okay, this one is related with the, here, case 8, anomalous cases, period 2. There are 2 cases, beryllium versus boron and nitrogen versus oxygen. Same thing happened for period 3, magnesium versus aluminium and phosphorus versus sulfur. So let's check what happened. Okay, if we check, right? Okay, according theory by right? Okay, when across a period, right? Okay, the size getting smaller. Okay, when the size getting smaller, okay, this one across a period, size getting smaller. So if you want to remove an electron, you need more energy. So IE sure increase, but increase, right? By right, the graph should be linear graph. Increase like this, but you notice here boron, beryllium. Boron by right should be higher than beryllium, but suddenly drop. Okay, same for here. Nitrogen, oxygen supposed to increase, but suddenly drop. Why? Okay, this one you have to check for the electronic configuration. If beryllium, you notice 2s2. And then boron, 2p1. So 2s2 actually is a full field orbital. If you still remember for the chromium and copper, okay, this one must be 3d5. Okay, this one must be 3d10 because the half field and full field, right, there are extra stability. Okay, so that's why more energy is required to remove the full field 2s orbital for beryllium. That's why beryllium has higher ionization energy compared to boron. Okay, same thing happened for magnesium and aluminium. Just, okay, the electronic configuration for magnesium is 1s2, 2s2, 2p6, then 3s2. And then for aluminium is 3s2, 3p1. But the explanation is still the same. This is due to the completely filled 3s orbital. And then this one is 2p partially filled orbital. Okay, nitrogen, same thing. Just 2p3 is half filled. And then 2p4 is partially filled. That's why half filled 2p orbital, extra stability. That's why I need more energy. Okay, same for here. Phosphorus, sulfur, the same thing. Just phosphorus is 3p3, and then sulfur is 3p4. So the 3p3, like the 2p3, half field of p orbital, extra stability. So clear? Class? Hello?
Yes, madam.
Yes, madam.
Okay. So that's all for the anomalous cases for ionization energy. So now we go back to the question. The question, okay. Ionization energy for nitrogen. Okay, nitrogen is greater than oxygen. But, okay, nitrogen ion is smaller. The ionization energy is smaller than O positive. Why? Okay, for sure is nitrogen higher because 2p3. But once it's removed the electron, means the first ionization energy, now is we proceed for the second electron. Now you check. Now is O positive with 2p3. So stability of the half field 2p orbital. So this is the reason why N positive is lower than O positive for the ionization energy. Get it? Clear? Always refer to the electronic configuration. Okay, soalan ni dia tanya, mengapa, okay, nitrogen, ionization of nitrogen memang lebih tinggi daripada oksigen kerana dia 2p3. So, kerana half field. So, extra stability. Tapi semasa remove electron, jadi lepas dia buang satu electron, nitrogen akan jadi 2p2. Masa ini, oksigen positif yang jadi 2p3. That's why nitrogen positif sekarang ionization energy dia kurang daripada O positif. Reason? Inilah 2p3. So always refer to the electronic configuration, and then after remove what happened. Okay, now among element magnesium, sodium, silicon. Okay, second. Okay, first of all, after remove one electron, it will remain 2p6. After remove 3s1. After remove 3p1. So which one has the highest second IE based on this valence electron? The answer is sodium. Sodium, why? Highest second IE, you check 2p6 because it's come from the full field 2p. Okay, full field inner shell 2p orbital. Or you say full field 2p orbital, which is inner shell. Okay, the term full field is 1 mark. Inner shell another 1 mark. Dulu kita cakap full field 2p orbital je, tapi ada satu tahun keyword inner shell kena ada. So that's why kena ada full field. Yes, dan memang full field 2p6. Pada masa yang sama, yes, inner shell tadi 3 sekarang jadi 2. So that's why full field inner shell 2p orbital. Okay, soalan madam nak tanya sekarang. This question, based on this question, between sodium, magnesium, silicon, which one has the highest first IE? Second IE tak tahu jawapan. First IE. Yang mana ialah mempunyai first IE yang paling tinggi. Okay, sila tuliskan jawapan anda kat chat. Sodium ke, magnesium ke, silicon? Okay, semua orang kena tulis Harris, what is the answer? Okay, Aida bagi magnesium, Fatihah bagi magnesium. Okay, I pun bagi magnesium. Yang lain sila jawab. Okay, madam boleh check respon I boleh check respon. Apa yang ditulis kat sini, I akan Tam pun magnesium, Putri pun magnesium, semua magnesium. Ada jawapan lain? Tak ada jawapan lain ke? Memang magnesium ke? Mengapa magnesium? Okay, Najihah, mengapa magnesium? Okay, Wong pilih sodium. Okay, Najihah mengapa magnesium? Buka mic, sila terangkan. Cuba. Ataupun siapa-siapa nak cuba, mengapa magnesium? And then why is sodium? I asked about first IE. Now I change the question, first IE. Which one has the highest first IE? Jangan terima je, kena fikir. Alvin, silicon. Okay. Okay, Nak Jiha sila buka mic. Boleh tak? Jiha, cuba. Hai Jiha. Jiha jangan malu-malu. Okay. Lokman. Lokman sila buka mic.
Dia sebab S2 madam.
S2. S2. Okay, S2. Dia sebab S2. Okay, Wong. Terima kasih. Wong, why you choose sodium?
Because of the effective charge.
Oh.
And
Oi? Effective charge. We didn't talk about effective charge. We talked about effective nuclear charge. Okay. Effective nuclear charge. Okay, since you mentioned about effective nuclear charge, let's check the effective nuclear charge together. What is the effective nuclear charge for sodium? Okay. The blue line is indicate the inner electron. So what is the effective nuclear charge for sodium? Wrong?
One.
Positive 1.
Yeah.
Okay, then this one?
Positive 2.
This one?
4.
Okay. So based on here, which one has the highest effective nuclear charge? Kelas yang mana paling tinggi?
Silicon.
Yes, the answer is silicon. Do you notice? N equal to 3. So meaning that if we compare sodium, magnesium, silicon, actually we are comparing across a period. When across a period, what happened? Okay, so that's why don't be confused by 2s2. I know why you choose 3s2 because you thought it's fulfilled s orbital. You have to be careful. Okay, anomalous cases only happen, okay, when there are, for example, nitrogen, oxygen. Okay, this one, nitrogen, oxygen, and next is sulfur, phosphorus. Another case is aluminium, magnesium, and then beryllium, boron. Okay, only these 4 cases is due to the full field or half field extra stability. But the rest, right, we still stick to shielding effect or principal quantum number, shielding effect principal quantum number, or effective nuclear charge. We check for the proton number. In this case, all n equal to 3 means same period. If same period, we check across period. Okay, of course you have to be careful about the anomalous cases. Again, just now we discussed this one, the anomalous cases. Okay, so for this case, sodium, magnesium, silicon, we still stick to across a period. So the highest first IE is silicon. Okay clear? Be careful Okay. Saja nak tanya kita, madam tahu, madam akan tahu, you all akan jawab salah. Tapi saja supaya you nampak. Okay. Now last question for ionization energy. Okay, in this case, okay, the table show the electronic configuration WXY. So this is the ion. Okay, let's try. The question asks, explain the difference in the first IE again between W and X. W and X. N equal to 3. Get it? Okay. So which one higher? W or X? Plus N equal to 3 as well. Yes. X. Why? Because this one group 1, this one group 16. 16 2 campur 4 sama dengan 6, P block tambah 10, group 16. So across period. Okay. So X has higher ionization energy. Okay, ataupun itu tak boleh tahu W is lower than X. Okay, up to you. You boleh cakap higher ataupun lower. So berjalan bagi lower because across period the valence electron is more difficult to remove as the atomic radius decrease. Okay, penerangan ini dia kurang satu apa? Dia kurang 1 point. Siapa boleh beritahu saya kurang point apa? Dia kurang 2 point, bukan 1 point je. Effective nuclear charge. And then attraction. before you give this answer, right? Okay, yes, first ionization W is lower than X because across period, effective nuclear charge increase. So the attraction between the nucleus and the valence electron, is stronger. So the valence electron is more difficult to remove as the atomic radius decrease. Okay, please take note. Okay, now the difference of ionic dyes between X2 negative and Y2 positive. X2 negative, okay, meaning that 2 electron is added. So it will become 3s2, 3p6. And then Y2 positive, meaning that remove, become argon, meaning that now there are isoelectronic species. Sama je. Okay, argon maksudnya dia guna simbol noble gas untuk menggantikan 1s2, 2s2, 2p6, 3s2, 3p6. Nyonya lah 1s2, 2s2, 2p6. Okay, meaning that now both of them having the same electronic configuration. If same electronic configuration, you sudah tahu dah, mesti N ion lebih besar. Kerana effective nuclear charge. Okay, the ionic is smaller, yes, because the effective nuclear charge of Y2 plus is higher than X. Okay, mungkin ada orang dah tahu, effective nuclear charge macam mana tahu? Okay, senang je. So for this case, what is the proton number? Okay, kalau siapa yang tak clear, kita buat sama-sama. 1s2, 2s2, 2p6. Dia tak bagi tapi kita boleh kira. So here, right, okay, kat depan sini dia ada 10. 10 campur 6. So this is 16. The Z, the proton number for X is 16. Okay, for this case, 10, 18. Okay, for this case, Z is 20. Siapa tak faham? Proton number for X is 16. Proton number for Y is 20. Okay, now 16 minus the electron. So their electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6 now. So here consider the inner electron. Minus 10 equal to positive 6. And then here 20 minus 10 is equal to positive 10. So always write positive 10. That's why Y2 positive has higher effective nuclear charge. Okay, compared to X2 negative. Always remember when you answer this kind of question, you must compare. So the compare like this. The compare should be like this. Y2 positive is smaller than X2 positive. Why? And then nuclear charge of Y2 positive is higher than X plus. Always compare. Don't give the general explanation. Kerana soalan khas tanya XY, you kena jawab berdasarkan XY. Okay, that's all for ionization energy. Okay, if electronegativity, this question is simple, define. And then just give the general explanation because the question is in general. Okay, explain qualitatively the variation of electronegativity across the period and going down the group. So if based on here, right, okay, this is the definition of ionization electronegativity. Relative tendency of an atom to attract electron to itself when chemically combined with another atom. Okay, then what happened across period? So based on here, right, I'm not encouraged to use the explanation from here. No. Okay, refer to my notes. Okay, try to use the complete one like this. Ionization electronegativity. Okay, this is the basic one. Follow the explanation like this. Okay, class, cannot. So this is the explanation across the period and going down the group for electronegativity. As I explained just now, the first is the first, second, third, fourth point is the same. So the difference only here. Whether it's easy to attract or difficult to attract. Easy to attract, electronegativity increase. Difficult to attract, electronegativity decrease. Because now we are talking about the tendency to attract the electron. If easy to attract, yes, the electronegativity increase. Difficult, electronegativity decrease. Okay, a big difference with IE. IE is remove. IE we talk about remove electron. If easy to remove means less energy is needed. So that's why IE, okay, suppose it's here. When IE is to remove electron. So when going down the group, easy to remove. Easy to remove. Easy to remove means less energy is needed. So that's why IE decrease. But for across a period, IE, okay, IE, okay, across the period, IE, okay, we know as no remove electron. For across period, difficult to remove. Why difficult? Because the size is smaller, the attraction is stronger. That's why I need more energy to remove an electron across period, so high IE. Here, always refer to definition and then only explain according to size, effective nuclear charge, or shielding effect. Okay. Question 14, highest melting point. Okay, highest melting point is chapter 4. If we need to explain highest melting point, right? Okay, skip first. Okay, diatomic molecule, group 17. Second IE, we discussed just now, sodium, because from 2p6, that's why sodium form an inner completely filled orbital. Okay, form amphoteric aluminium. Okay, so please, when you form amphoteric, right, and write the equation, this statement is a must. You must write out add as base means the aluminium oxide react with acid. Must write out add as acid, and then meaning that the aluminium react with base. Okay, classification should be no problem because classification, right, group 1, group 2 are alkaline metal and alkaline earth metal. That's why it will form alkaline oxide. So magnesium, sodium, alkaline oxide. And okay, the rest non-metal, okay, it will form the acidic oxide. Okay, the special one is aluminium, amphoteric. Okay, so aluminium amphoteric, when you write the equation, right, remember must add as base means react with acid, add as acid, react with base. Okay, now look at here. This is a concept for chapter 4. I just brief you all first. When we talk about the melting point and boiling point, right, we have to be careful. We have to divide it into 3 parts. First is here, metal. Okay, next is non-metal. And then the special one is this one, silicon. Silicon is metalloid. If we compare, right, you check, the highest melting point is silicon. Okay, but across period 3. Why? Because due to its structure. Okay. The structure of silicon has the highest melting point because due to the giant molecular covalent structure. Okay, I prefer use the giant, okay, giant molecular covalent structure, and then each silicon is tetrahedrally covalent bonded to 4 other silicon infinite. Okay, if you use the lecture notes and see, right, let's check out whether got or not. Yeah, got. Okay, so this one is giant covalent structure, giant covalent structure. I can remind a giant covalent structure. So this is the silicon. One of the silicon, right, okay, can bond it to another 4 silicon to form the covalent bond. Due to this connection, right, okay, it form a big structure. So for a big structure, we call it as giant covalent structure. Okay, covalent bonded, so 3-dimensional array. Due to these features, okay, that's why silicon has the highest melting point if across period 3. Okay, after that is metal. Sodium, magnesium, and aluminium have to base on the positive charge and the size as well. So that's why when we talk about metallic structure or the sodium, magnesium, aluminium, we have to talk about metallic bonding. And then metallic bonding depends on the electrons, is the electrostatic force between positive metal ion and the delocalized C of negative valence electron. So this is a diagram, okay, for the electron C model for magnesium. Always remember, if there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, if there are 12 magnesium ion, meaning that 12 times 2, there must be 24 of electrons for this diagram. Okay, due to magnesium is solid, right? That's why it's arranged in orderly. Okay, so strength of metallic bond is proportional to first, number of valence electron. Second, inversely proportional to atomic size or positive ion. Okay, So that's why if compare sodium, magnesium, aluminium, aluminium has the highest melting point compared to these two metals because aluminium 3 electron, 3 valence electron, and the size of aluminium is the smallest. Get it, class? Boleh? Boleh masuk lagi? Last dah. Okay, yeah? So now, okay, now we proceed here. This objective, this question. So has the highest melting point. Phosphorus non-metal, chlorine non-metal, argon noble gas, aluminium and sodium metal. Okay, aluminium with 3 valence electron. And then the size of aluminium is the smallest if compared to sodium. So sodium only has 1 valence electron. So that's why the answer is aluminium for this case. Okay, so this is what I mentioned. Melting point of sodium to aluminium 5 because it depends on the strength of metallic bonding is proportional to the number of valence electron. So aluminium, magnesium, sodium 3, 2, 1 respectively. Okay, of course you have to mention the size as well. Meaning that one point is missing. Forget explain about the size. Okay, silicon no problem. Okay, the last part for the non-metal. For the non-metal, we check for the molecular size because it only has simple molecular structure, and then the simple molecular structure is directly proportional to the size of molecule or the atom. Okay, the forces is van der Waals forces. So that's why S8, P4, chlorine, argon. Argon is the smallest, is the lowest melting point. So if we check the sequence, right, the sequence should be like this. So silicon first, then aluminium, magnesium, sodium. Next is sulfur. Okay, then only phosphorus, chlorine. Okay, okay, group 16. This one is group 16, this one is group 15, this one is group 17, meaning that it's not related with the group, but we check for the molecular size. Okay, sulfur will form S8, phosphorus will form P4, chlorine Cl2, argon monoatom. So we check for the lecture notes and then we notice, right? Okay. Okay, this is S8. This is the simple molecular structure for sulfur, chlorine 3 atom, argon just monoatom, and then the phosphorus is P4. So the van der Waals forces of attraction increase as the molecular size increase. Here, you have to know between argon, chlorine and chlorine is covalent bond. And then chlorine molecule with chlorine molecule is van der Waals forces. Different type of forces. Madam ulang, you have to be careful. Okay. The combination for the sulfur, the S8, right, is covalent bond. Strong covalent bond. But between S8 versus S8, right, here is van der Waals forces. It's a weak forces. Van der Waals forces is a weak forces. Bond, yes, strong bond between the S8 molecule. But the intermolecular forces between the S8, S6 is van der Waals forces. So the covalent bond within the molecule are very strong. But the van der Waals forces of attraction between the molecule are very weak. So the van der Waals forces of attraction is depends on the molecular size, directly proportional. Okay, always remember non-metal, simple molecular structure, and then for metal, right? If due to strong metallic bonding depends on the electrostatic force between the positive metal ion and the delocalized C of negative valence electron. So it is directly proportional to number of valence electron, inversely proportional to the size of positive ion. Okay, I think that's all for today. So let's check the exercise, the last part. Okay, for today, right, I have discussed all the tutorial question with you all. So you no need to do the tutorial question for chapter 3. Good or not? Or you want to do it?
Good.
Good, okay. Okay, later I will share the recording video so you can try to listen again for the explanation. I have discussed all the 3.2 tutorial with you all and all the 3.2 periodicity, okay, the explanation for periodicity. Okay, we try to do the last part, the objective question. Okay, let's do it together. Okay, read the question and then tell me the answer. Highest melting point. Which one?
Silicon.
Yes, silicon. I did explain just now, silicon. Due to the giant molecular structure. Okay. Basic, amphoteric, acidic. As we know, amphoteric only aluminium oxide. So out. So between F and H, which one? Basic must be metal. So yes, metal, yes, metal. And then acidic must be non-metal. So answer?
F.
F.
Okay, be careful. Haha. Which of the following arrangements show the order of increasing ionic reactants? They are cation and anion. So this is what I said just now. Period 3. So there are sulfur, phosphorus and sulfur, period 3. And then come to period 4. Okay, which is potassium. Okay, phosphorus, sulfur, chlorine. Okay, and then potassium. And then potassium will form the cation. And then this one will form 3 negative, 2 negative, negative. So which one is the smallest one? Smallest? Once you identify the smallest, everything will be easier. Phosphorus ion, sulfur ion, chlorine ion, and potassium ion. Which one has the smallest size? Smallest ionic size?
Potassium.
Yes,
Potassium.
potassium. Okay, remain to answer. Out. So which one has the largest size?
Phosphorus.
Yes, phosphorus. Semakin negatif, semakin besar, semakin positif, semakin kecil. So the answer is B. Okay, question 4. Which of the following statement are about, okay, first of all, you must calculate the ratio. Okay, everybody, please tell me the ratio. So this is IE2 to IE1. Please take out your calculator, do some exercise. IE3 to IE2. This one, IE4 to IE3. Okay, so please tell me the value for Y first. Anyone? Tekan calculator, Brida madam, Kira. So what is the ratio? I'm waiting for your answer. Tekan calculator. Hi, just give me the answer. There are 48 of you. Everyone give one answer. So what is the answer? Just give one.
2.94.
2.34. How about this one?
4.78.
4.78. One?
1.37.
1.37. Very good. How about X? Z?
Madam,
Yes.
question 3, not A.
Oh yeah, oh, sorry, yeah. yeah. Okay. Okay, what I say, and this, be careful. Sometimes you are talking like this, right? But you choose the wrong answer. Be careful, especially during quiz. Okay, P3 is the largest. So P3 is the largest here. Yes, the answer is A. Thank you, Lim. Lim or Tam? Lim, right?
Tam.
Tam. Okay, thank you, Tam. Okay. Z. What is the value for Z? Z. Okay. Avish, where are you?
Yeah.
Take out your calculator and press it. Lokman. Kan sini ada Firdaus kan? Ada Firdaus tak? Ada kan? Kita buka tengok siapa dia. Semua orang jangan malas tekan calculator. Lagi banyak. Danny, ni Syami. Please give madam the ratio value. Okay, let's continue. Okay, what is the answer for the IE2 to IE1 for Z? Near to 3, right?
3.3.
3.3. How about this one?
4.17.
4.1 something. Okay, this one?
1.31.
Okay, 1.31. Okay, actually very fast only. When you calculate this, right? Okay, you can notice, right? You just need to find the highest IE ratio. So this one is the highest. Okay, this one is the highest. So based on here, I'm circled at the same place. Means the IE3 to IE2 is the highest. I know they are belong to the same group. Which is group? What is the group for these two elements? Yes, group 2. Group 2. Okay, because IE3 to IE2 is the highest, so group 2. And then the third electron is from the inner shell and completely filled. Okay, now we check. Okay, with positive 2, correct? Okay, I check for the easiest. Okay, belong to the same group, yes. Okay, now we go back to question 1. The size of Y is smaller. Y is smaller. Yes, Y is smaller because higher IE. Higher IE, smaller. So the answer is 1, 2, 3. Yeah. Question number 5. D block. Do not change significantly. Yes. A not related with screening effect. Are added to the inner cell. Yes. The effective inner charge do not change much. Yes. So the answer is 1 and 2. Okay, which is B. Just now 1, 2, 3 is donkey. Yeah. Okay, 4 donkey, 5B. Am I right? 4 donkey. Yes, 5B. Yes. So you can do it by yourself actually and then check. Going down the group, what happened? Electron negativity decrease. Yes. Difficult to attract the electron. Metallic properties increase. Yes. Okay, always remember, metallic properties is depends on the ease to remove the electron. Semakin senang buang electron, semakin tinggi properties. Okay, ease of cation formation. Yes. So 6 donkey. Am I right? Yes, 6 donkey. Okay, 7. Sodium, magnesium, aluminium, which of the following explain the trend? Effective nuclear charge increase, yes. The number of electrons are the same, but the number of protons increase. Huh? Yeah, correct. Because isoelectronic species. Proton increase. Yes, because 11, 12, 13. The number of electron and proton is the same. No, not the same. Because remove electron already. That's why electron is the same, but the proton, no, not the same. Because one is remove electron, the electron will be lesser. Okay, so answer? Yes, 1 and 2 correct. 1 and 2. So that's why 1 and 2 is B. Okay, now the same thing. Okay, class. 1s2, 2s2, 2p6, 3s2, 3p3. Okay, Katiani, Katika, right? Kati, one of your friends, Kati. Okay. I want to find someone. Okay. Saya random nak pilih seorang. Tak pilih siapa? Okay. Fatihah, are you here, Fatihah?
Yes, madam.
Yeah, Fatihah, let's answer this question. So what is the group for this case?
3.
Group? What is the group for element P? What is the period for element P?
50.
Tak dengar dengan jelas? Ulang sekali lagi. Thank you.
50. 50. 2.
Ataupun you type. Madam tak dengar. Cuba group 50. Yes. Period. Period berapa? Tengok balik period berapa? Yes, very good. Okay. Yes, period 3, group 15. Be careful. 3 plus 2 equal to 5. Block P, that's why 15. Okay. So group 15 metal or non-metal class? Group 15 metal or non-metal?
Non-metal.
Yes, non-metal. So non-metal, is it will form basic oxide? Correct or not?
Not.
No. Yes. Okay, P is found in the third period. Yes, period 3. The electronic configuration, is it correct? Madam silap kira ke? Oh, ya, betul Madam silap kira. 1, 2, 3s2, 1, 2, 3, 4. Okay, sorry, suppose 3p4. Yes, Madam silap kira. So 3p4 is 6, school group 16. Okay, so the answer is 2 and 3. C. Okay, that's all for today's lesson. This is all about periodic table, periodicity. Okay, so again, for periodicity, right, we must know what is shielding effect, special to discuss about when going down group, and effective nuclear charge for a cross period. And then the size, there are 5 cases. We need to discuss the size of the atom across a period, going down group, or across the first row of transition element. And about the ionic radii, right? Okay, if in general, actually it's same as across period and going down the group. So that's why variation in atomic and ionic radii is in general for the across period and going down the group. The special one is when we compare the atom with its cation, or we compare the atom with its anion. So this is the title for case 4, compare the atomic radii of an element and its corresponding ionic radii. Example, sodium ion, chlorine ion. Case 5 is about isoelectronic species, means all the element, right, or all the ion with the same electronic configuration. Then we have to compare in terms of effective nuclear charge. If the n value is the same, if the n value is different, we have to compare in terms of shielding effect. Okay, next, ionization energy. We must know how to describe and define first ionization energy, and then what happened with the cross period and going down the group. And then for ionization energy, there are few anomalous cases. Okay, for period 2, between beryllium, boron, and nitrogen, oxygen. For period 3, between magnesium versus aluminium and phosphorus versus sulfur. The explanation for beryllium, boron, and magnesium, aluminium is the same. Okay, due to the fully filled 2s orbital. And then for the nitrogen and oxygen, and phosphorus, sulfur is the same due to the half-filled 3p orbital or 2p orbital. So you can check it by using electronic configuration or orbital diagram. And then we learn about the successive ionization energy based on graph or based on the table. And then based on this successive ionization energy, we can deduce the position or the electronic configuration of that element. Okay, next is about the electronegativity. This one simple, just know, define, and what happened when across period and going down the group. And then the last cases for this chapter is about the acid-base character of oxide of element in period 3. Simple, you just need to identify which one is metal, which will form basic oxide, and then for the non-metal, we form the acidic oxide. And then aluminium is special. Aluminium oxide is amphoteric. It can react with acid and it can react with the base as well. For this part, we need to know how to write the equation. Okay, that's all for today.
Thanks for watching. Please do remember, subscribe my channel and follow my IG, TikTok, and Facebook. See you all again on next video.